So we're given this graph and we want to analyze the hyperbola and get our relevant information. The first issue is the center, and the center is at 0, 0. So not a whole lot to worry about there. Next, our transverse axis. So is it horizontal or is it vertical? Transverse axis is horizontal. So it is the x-axis or the line y equals 0. A lot of ways to describe that. Now you know that the vertices, the vertexes, live on the transverse axis. So where are they? Here is a vertex at 5, 0, and there is a vertex at -5, 0. So that helps us determine that on the transverse axis where it hits the hyperbola. So vertices (5, 0), -5, 0. So our span in x is going to be 5. Now remember, since the transverse axis is horizontal and since the center is 0, the equation will be x squared over something minus y squared over something equals 1. So we've shown again that the span in x is 5. Just to clarify that. From the center to the vertex, 1, 2, 3, 4, 5. From the center to the vertex, 1, 2, 3, 4, 5. So 5 squared, transverse axis is horizontal, x comes first. So it'll be x squared over 5 squared minus, now what is the span in y? What is the span in y? Well, we get that from looking at our asymptotes. So it helps that I drew this little box for you. If I hadn't have drawn this little box, you need to determine the asymptotes. From there, you'll notice it goes up 2 to get to the asymptote. It goes down 2 to get to the asymptote when x is at 5. So the span in y is 2. So since we said the span in x was 5, that gave us this thing, a squared is 5 squared. The span in y is 2. So b squared will be 2 squared. So we have our equation now of our hyperbola. X squared over 25 minus y squared over 4 equals 1. We also want to get the equation of our asymptotes. So let's take a look at that. Again, rise, 1, 2, run, 1, 2, 3, 4, 5. Up 2 over 5, slope is 2/5 x, y-intercept is 0. So one asymptote is y equals 2/5 x. Rise 2, run 5. Span in y divided by span in x. Y is 2/5 x, and then of course, the other one is just the negative of that. Let's see it. Down 2 over 5, right? Slope is -2/5 x. Y-intercept is 0. So the other asymptote we get is y equals -2/5 x. Now it'd be nice to find our foci, our focuses. So where are they? What do we have? Well, let's go ahead and graph our function on Desmos if we can, just to kind of see where we are. So we're saying x squared over 25 minus y squared over 4 equals 1. And there you go, you see the shape of those guys. My vertices were at 5, 0 and -5, 0, as we said. And our asymptotes were 2/5 x and -2/5 x. And let's make them look like asymptotes. And it's always good to kind of zoom it out so you can see the asymptotic behavior that as we move away from the center, the hyperbolas get closer and closer to those lines. Okay, but we want to find the foci. So remember, the hyperbola envelops the focus, the parabola envelops the focus, the ellipses envelop the focus. The focus is in here somewhere, focus is in here somewhere. How are we going to find it? Well, we have our equation. Our equation is x squared over 25 minus y squared over 4 equals 1. And for hyperbolas, what do we say? We say c squared is a squared plus b squared. So c squared is 25 plus 4. So c squared is 29. So c is plus or minus root 29. From the center, we said the center was 0, 0. So root 29 is a little bit more than 5. 1, 2, 3, 4, 5. Root 29 is there. So my focus is at root 29, 0 on this side, and at negative root 29, 0 on that side. So foci on the transverse axis, root 29, 0, negative root 29, 0. So let's go back and look at our screen. Let's see where root 29 is. Square root of 29, comma 0. Notice the hyperbola envelops it, surrounds it. Negative square root of 29, comma 0. And those are our two focuses. And remember that the hyperbola is a set of points whose difference of distances from the two foci is constant.